tutorial. Yeah, I'm here every tutorial unless for some reason I get called away to a meeting or something.
This is like the end of class, and there's like a speaker and like this assembly there. Do you think I can take like if I had to just not like? Do you think I can take this as a tutorial? Like I'm. Or do you want like? I try to take it and I don't tell you.
Well, if you do better on a future test, then it will become formative where it won't count.
Oh yeah.
So if you're here, I'd rather you wrote the quiz, and then we're gonna have one every week like that.
Is it usually like? I guess like it depends, but like if we have like this class first, then it'll be fine. Just 'cause like. I don't know.
Yeah, over the course of the day. Yeah, no, I understand. But yeah, you're gonna get that on Friday times.
Yeah.
That's gonna be on day. Yeah.
Okay.
Okay. Well, we are.
If you have sand in big
Tell
water.
me something and I'll identify it as one of these.
Milk.
Milk?
We did all that. Nice.
Yeah.
Hold it. Are we?
It's like chemically bonded as well. You need like chemical stuff in the body. Except for it.
We were up to here last day. This is us, right? Yeah. Sort of. Yeah. Okay. We'll continue from there when we start. Okay. What time is it? That's not the bell to start class. You still have 5 more minutes despite the bell. Officially, when they change the blocks, we don't start till noon. So you may talk.
We still have 4 minutes.
But at the same time, your phones can't be out. Because they're not allowed to be out any time you go. Unless invited to by the teacher. Yeah. This year.
Could you invite us?
Pardon?
Could you invite us for these 4 minutes?
Yeah, good. You're invited to use your phones for the next 4 minutes.
Let's go, Zal.
Well done.
Are we allowed to use periodic table on that?
Oh yeah, absolutely. You will get one quiz in which you do not get the periodic table, where I literally ask you to memorize some things about the elements. That's mostly to help you with naming. It's just to encourage you to remember things because you're just faster if you do.
I guess. To assembly.
But for every other one, yeah. Did yours go missing? Where's your button? Oh. Do you have your note package here? You might want to go get that. The quiz is at the end of it. It's not a test. It's not going to take up the whole test. No. Quiz will be at the end of class. You will have sufficient time for not only the quiz, but 50% extra time if you have 19 because it's before lunch. And if you stop at 1 o'clock, you will have sufficient time for 100% extra time after that if this is over. So you have plenty of time. It's only a 12-mark little quiz. If you're wondering how time is calculated, for most questions in high school, regardless of grade actually, 1 minute per multiple choice, 1.5 minutes per mark in long answer. So 2-mark question would be 3 marks, 3 minutes.
Oh yeah, I saw. She nice? She's nice. I think she's in like grade 12. She Oh.
I think that's the only thing that was kind of
What? What's suspension?
hopefully it's just like what is yogurt. What is a suspension?
What's suspension?
Separate over time between two.
Yeah. Yeah, it doesn't fully dissolve it. Like after like a while it separates. Isn't I mean
When you go like this, yeah. Because it gets
I like it homogeneous. They put it in a centrifuge.
yeah. How about
Okay, you should be prepared for class, even if we haven't started. Make sure your notes are up from last day. You turn to this page. 5, 4, 3, 2, 1. Classes in session. Okay. I believe we were here last day, and given that we're coming back to it, I am going to just quickly go over it rather than having people come up. 1 electron, 3 protons, that should be 2, 1, 2 electrons, 4 protons, 2, 2. This is, looks like it got shoved to the side. And why don't I get some people to help? I will be asking you for various numbers on here if you have it in front of you. Let's quickly do attendance. So we are B block and Alexander,
here?
Aria, Ariel,
Yeah.
Charlie, Jing Chao,
Yeah.
Eric,
Yeah.
Guy,
Yeah.
Isaac,
Yeah.
Isabel, Jessica, Katie, Katie who? Okay. Kiona, Natsuho,
Yeah.
Sihu,
Yeah.
Sterling,
She
Sterling.
went to get a thing.
Oh, right. Jaden,
Yeah.
Tom,
Yeah.
Tyler.
Yeah.
Oh, all here. Excellent. So now I can do random. Looks like we lost the number of protons to boron, even though we had the other thing. I'm going to ask, so as I go through and I fill in the rest, I'm going to ask the number of protons. Katie. For boron. Boron. If everybody has their periodic table in front of you, it'll help. 5. So that makes the correct electronic structure. Carbon has how many protons? Eric?
Have 6.
6 protons. And let's say someone else for the electronic structure here. Jessica.
For carbon,
Yeah.
4.
Just 4?
Oh no, there's
Oh,
but it's 2 and then 4.
2 and then 4. I think you jumped ahead and gave me the valence electrons.
Yeah.
Yep. It looks like this might have gotten erased. This is in fact 7 protons. The electronic structure then for that would be Sterling?
Not here.
Hold it. I marked him as here, did I not?
Yeah, she's here. She just went to get.
Oh, she went away. And I just gave her a point. Negative points. It's hard to give negative points. They make it really difficult. Needs work. Tom. Electronic structure. Where's Tom? What is the electronic structure? What is the electron pattern?
7 protons, 2 electrons, and then 5 electrons.
Yeah. So the electronic structure is 2, 5. And the number of valence electrons for that same one, please. Jaden.
Wouldn't it because we're doing likely electronic charge for each atom?
Oh, we're not doing a likely electronic charge. We're just doing atoms.
Oh, okay then.
So what's
5e.
pardon?
5e minus.
5. Yep. 8 to 6, a 9 to 7, 10 to 8. That's good. There's some weird lines going on over here. Ah. 10 to 8. We've got 2 up there, 2 up there. Valence electrons. I'm just going to.
I think you stole the valence electrons.
I think I did.
They're in oxygen.
They're in oxygen?
The valence electron.
Oh, there it is. Hold it. Here?
Yeah.
Oh, yeah. Yeah, look at that. Delete. Eleven to 8, 1. Going down to the side because it's getting squished. 1. 12 protons. And that says I suspect that was supposed to be 2 electrons to start off with, but it wasn't quite finished. So why don't we finish that one off? Ariel.
282.
282. And continuing Ariel. Ooh. How many valence electrons does that then mean? 2. Okay. Aluminum. 13, 2, just to make it clear. 8, 3, 3 electrons, 2, 8, 4, 4, 14 protons, 15, 2, 8, 3. 2 plus 8 is 10, plus 3 is 13. So phosphorus, I don't think so, unless they wrote that really funny. Tyler, what number should be here?
For phosphorus?
Yeah,
Let me check. 5.
5. And what's the number of valence electrons?
5.
Also 5. Excellent. Sulfur just looks like someone went mad. Okay, I didn't mean to start coloring it red. So, why don't I, if I'm going to color it anyway, make it a good color. Let's go with rainbow. Excellent. And then we'll do it in that one. Okay. How many protons does sulfur have, please? Kiona.
Oh,
16. 16 protons. And what would the electronic structure be, please, Isaac?
2,
2,
8,
8,
6,
6. Excellent. And the number of valence electrons?
6.
Excellent. And then we have, I think this one, maybe that one just got moved over because here we have 2, 8, 6. So now I'm thinking that maybe it got moved around like it sometimes does. So let's get rid of that. Chlorine, oh, it also doesn't have 16 protons. Let's fix this. Number of protons in chlorine, please, Charlie. 17, excellent. And then the electronic structure, please, Aria. 287, 287. Last one, Isabel. Where's Isabel? Excellent. Do the whole thing. Protons, electronic structure, valence electrons.
18. And then 8, 8. Yeah, and then 8 electrons.
Excellent. Oh, and I forgot the valence electrons there. And I'm just going to do the last two. Well, no, I'm not, because off the top of my head, oh yeah, of course I can. Because they're right there. So that was 18. This one would be 19 proton. That's way too big. 19 protons. And it would be 2, 8, 8, 1. 20 protons. 2, 8, 8, 2. Now if we stare really hard at this, what is the number of valence electrons for lithium? 1. Sodium? 1. Potassium? 1. They all have the same number of valence electrons. What about beryllium, magnesium, and calcium? 2. And they're all the same. You'll notice this is a repeating pattern on the periodic table. There's 1. We've got 3 and 3. We've got 4 and 4. We've got 5 and 5. 6 and 6. 8. Ooh. Nope. 7. 7. And then 8, 8. However, it's not here for helium seems to break that trend. How is that still following the trend? Anybody know? Yep. Has a full shell. These have full shells. Only 2 fit in the first one. This has full shells. To form an ion, and we're going to do something in here in a second, but I wrote the same thing twice. Write the electronic charge for each ion. No, electronic structure for each likely ion. And that is to form ions, atoms take the most efficient path to a complete or empty valence shell. Which I will explain because it's actually, the explanation sounds more complicated than actually doing it is. Because it comes down to atoms are lazy. In fact, the entire universe is lazy. We always want everything the lowest energy state. You're not going to spend a lot of work getting to somewhere if you could spend less work getting there instead. So first I'll let you write that down so I don't talk over your writing here. Eye on the time, so I'll make sure that you have time for your quiz. Okay. Let's take hydrogen. No, hydrogen is stupid. Let's take lithium. What we mean by the most efficient path, it turns out that empty or completely full valence shells are particularly stable. You can either get rid of all the electrons or you can add electrons. And you want the simplest way to do that. So lithium, what could it do to its valence shell to be full?
Get rid of 1
It could get rid of 1, and what's the alternative?
Add 7.
Add 7. Which is simpler? Remove 1. So its electronic structure then would be 3 protons and then just 2. Wouldn't have the 1. And what charge would it be? Plus 1. And this whole column turns out to be plus 1 for the same reason, because they got rid of 1 electron. Electrons are negative. Give you an extra proton. If you ever want to know the charge of something, you go protons minus the total number of electrons. It has to be the total number, not just the valence, and you'll always get the charge. So if I was to demo one, let's do boron, which is 5 protons. And I just mimic what was up there. It's 2, 3. It would have the choice of either getting rid of 3 or adding 5. And which will it do? Get rid of 3. You'll notice I don't write the E for electrons. That's an extremely dense form of the Bohr model. It is assumed that numbers that come after, 2 comma, if you put those are assumed to be electrons. So we have this. And then below, I want you to write the most likely charge. So we have 5 protons, 2 electrons. What is the most likely charge? Plus 3. Or 3 plus. There is wars fought in textbooks as to which way you're supposed to write it. How many of you were taught that there was one specific way and any other way is wrong? You? What way were you taught? 3 plus. 3 plus? 3 plus. Excellent. I was taught plus 3. I was also taught an alternative method of organic naming by my UVic professor. And it turns out once I left UVic, nobody else in the world names them that way. He had his own special system. He was also an expert in that particular area, so he got to do it. Do the rest of them. So now your job is to fill it all in.
What card do you not have?
I have my binder.
Do you, where,
He forgot his
I
binder.
left my binder in English class. I'm sorry.
where's English?
No,
Woodward. Not Woodward, arts.
Arto.
Do you want to run get it?
Alright.
And you can always say, Mr. Neufeld, emergency, I forgot, because I don't want you to sit there. Or, I still have extras because I printed way too many. You want to just continue on here and you can rip it apart later and then staple it back together.
Thank you.
You don't have to run away.
What if, isn't, shouldn't hydrogen be equally as likely?
Huh?
It is.
I didn't discuss that. But I did say at the beginning, I was like,
let's do hydrogen.
I said, let's do hydrogen. I said, no, hydrogen's stupid. So I went down to lithium. Why is hydrogen stupid?
It can do
Can
both.
go both
Think of both. So it's not stupid. It actually has twice the chance of a date on a Saturday night. Hydrogen is bi. It can add electrons. It can take away electrons. It can be positive. It can be negative. So on your periodic table that's colorful, you'll notice they put it on both sides because it can act like a halide to be -1. That's known as the hydride ion. Most of the time, however, it gives one away and becomes an acid, hydrogen plus, but it can do both. Is there any other element in there that can do both? Carbon. Any other one? Silicon. There are other factors at play. As you go down the periodic table, you'll find they get more and more metallic, and they're more and more likely to give up their electrons. And the higher up they are, they're more likely to become negative, or at least act in covalent bonding. And that has to do with the size of the nucleus, not just its charge. But they still can do both. They just might have a preference for one or the other. Oh, don't, ignore the dark. It goes from 4 to 5. Yeah. The black section in the middle, does anybody know why that's there?
It's for like the split the metals.
Yeah, it's all the transition metals. And for this diagram, I just removed them so you don't even see them. And for this one, I forgot. So just pretend that's not there. Is it going live? Yeah, it is going live. Why is that not updating? There we go. And we are block B. Group maker. I'm going to make special groups of 1. Everyone, look up and write down your number somewhere. Just a little note. Except for Tom. Where's Tom? If you could write down 19 instead of 5. Everybody got their number? Excellent. Only 2 writing at a time. Please don't use your finger now. That number is the atomic number that you are responsible for. So those of you who got 1, nice job.
Wait, what do I, yeah, what do I, first guess?
What? What's what?
I have 1.
Yeah, so you're hydrogen.
Just do 1 plus minus or something.
If you have 1 where it can go both ways, so you get to choose. Does that make sense?
That was my mistake.
Well, that's the key. Neither is wrong. There's 2 right answers.
So either way, right?
Yeah, you get to choose. Oh dear. Are you okay to come up?
Yeah, I'm already up here.
Yeah. Do you need someone else to write it for you while you command them what to do?
No, it's good.
Okay. Oh no, you have to pick one. I want an ion. No, you want to pick one.
What?
That's what we often do to indicate, to say it could go either way, but I want you to pick an ion. Make a choice.
Wait,
No, as in like only for the sheet, but like.
Excuse me.
Up there, I want you to pick one.
it's already.
Yeah, I already did mine.
Oh, okay.
On the sheet.
Yeah, sure, because it's for your knowledge.
Oh.
Oh, what the hell? You cannot be saying.
Okay, wait, hold on. I'm gonna. Is that a razor? Wait, I'm.
Oh, too many people drew at once. That's what happened.
Okay.
Charlie, since you had it out, rather than take it away, I am going to give you a lecture.
Dang it.
About having your phone out. Do you know what task switching is in the brain?
Dang it.
Let's say you're writing an essay that you really like to watch.
I didn't do them.
You're watching Netflix while writing an essay. It used to be thought that humans can multitask.
Dang it, where's the
at the
eraser?
same
Is this
time
the
as what
eraser?
it turns out that's not how our brain works. What your brain will do is it will write the essay for
Actually,
like a
that's
period of
Wait,
time,
wait,
and then it will
let me
switch
charge.
its attention to the
Let me
Netflix.
erase this.
And then once it's got
Oh,
some
what?
thought, it'll switch back.
Back.
Your brain just goes back and forth like that. You task switch. It's much more inefficient than just concentrating on one, because the process of switching takes time. So that's why if you're watching Netflix and you're writing an essay, it will take you much longer to write the essay than if you weren't. And you won't really know the plot of Netflix. It will seem a little confusing because you're not getting all the details. Interestingly, even if your phone is off, but it's next to you, your brain task switch. In the last 10 years, they discovered the closer your phone is to you, the more it switches. And what you're checking for, did it buzz, did it go off, was there a message? And the closer it is, it actually disturbs your sleep the closer your phone is to you. And that's not just true of cell phones. That was true of like dial phones and all sorts of things. They just, people didn't sleep next to phones or other attention devices until recently, so they didn't notice it.
That's the handwriting on the board.
Have you ever had your
I
phone
was
in your
born
pocket
for
and you felt it buzz, but it didn't buzz? But your senses thought for sure you got a call? It's a phenomenon. Nobody's ever had ghost calls. Your brain is so freaked out that it thought it heard something, it actually fakes the buzz. Like, so you could actually just,
Let me erase this real quick.
I guess that's just me though.
No.
So that's why I say put it away in your bag, because at least it's that distance away. Oh my goodness.
I got you.
Don't try to fix the line, just write over it in a different color or something.
Wait, so what's this one? Dude. Stop. You stop. Not funny. Holy shit. 9 feet. I'm lost.
future, and your past, and your present. And I'm not good at it, and yet it still works.
Oh shit.
At one time, I was also a water witch.
It includes
I don't know what water witch is.
pure substance.
Oh, that's you get spring-still rod, or you tree, walk all the way in, and the ground will pull it down.
I think I did it right.
Water, and you take a
Like
walk.
the
If I did it wrong, it would crash out.
like
I was a kid.
I think
Turns out that's not what you're doing. There's a phenomenon that'll make it feel like that's what you're doing.
like carbon dioxide.
But if you don't know, it feels like it's really real.
Like yeah.
Okay,
For pure substances,
I am going
like
to-
water and carbon dioxide.
what happened here?
Because I've learned that it would be only elements, but wait,
Can
Mr.
I get,
Neufeld,
can I get, no, yeah, I think I can get rid, oh, that's the P. That's a really big, what if I did that? Nope. Let's just,
But then you remove also my plus.
there, where's your plus?
19. It's now only.
That's a plus.
No, at the bottom this line,
What?
it was a plus one.
This was a plus one?
Yeah.
But it's not plus one. Oh, the charge is plus one. There we
Yeah.
go. I fixed it. Okay. Oh, clever. Haha. Curse you, hydrogen. You made it -1, which means technically I drew the periodic table wrong. You didn't do anything wrong. I should have put it there, because now it's -1 with all those. Notice the number of valence electrons has still, in a family, has remained the same. And now it has become the same across the boards, because we have 2, 2, 2. But the charges are going up, +1, +2, +3. Now this one could have been -4. If you have 2, 8, and -4, you're entirely correct. This can go either way. 2, is that an 8? I'm going to assume that's an 8. Is that a 5? 1, 2, 3, 4, 5. I won't look up who 7 is now that I've said that twice, because I don't want to embarrass you. If you would be embarrassed, but that should be an 8. At least like that's an 8. What's that?
That's a 2.
That's a 2. But then why is it -1? Because they removed 7 electrons. Theoretically, if you just have 2 there, it should be +7. Yeah, so we need the 8 there. And that makes it -1. How many protons does this? Well, there it's 9. I think the 0 goes up there. And if you want to know how do you figure out the charge, well, 9 protons minus, that's positive, 2 + 8, 10 electrons equals -1. Protons minus electrons total electrons will always give you the charge. 2, 8, 8, so we have 17 minus 8, and 8 is 16, 17, 18. 17 minus 18 is -1, so that's a little too positive. I want to be a little more negative there. Notice you didn't have to do anything. If you were lucky enough to get a halogen, they all have a charge of 0. This is why, not halogens, my apologies. These are the halogens. We do periodic families later. What are these called? Noble gases. If we named them today, we'd probably call them the 1% or something. They have all the electrons they could ever want. They don't need any more. They don't want to give any away. They don't do anything. They don't do any work. They are unreactive. So we call them nobles, because nobles don't do any work. 2, 8, -3, 2, 8, 5. So we've added in an extra shell, but the outermost valence is the same. However, this one has 5. So this was 2, 2, 2, 2, and then boom, 2, 8, 2, 8, and then 2, 8, 2, 8, 2, 8. This is okay. 2, 8 plus 4, got rid of 4. It could have had 2, 8, 8. That would have been good. But this should be 2, 8, 8. Depends if you're...
Disappear.
Oh, okay, sorry. Thank you, thank you, thank you. 2, 8, 8 plus 2. 10, 18, 16 minus 18 is -2. Don't forget your signs. 288. So we already did that one. 2880. And then the last one I get to do. This one again becomes plus 1, 288. And of course, 20 protons. 288. It would have been 2, but we get rid of that. And this whole thing becomes plus 2. And this is why families share properties. Everything in here wants to become a plus 2 ion. So calcium, magnesium, strontium have very similar chemistries. They even can have similar functions in your body. Some of the dangers behind some of the radioactive isotopes are that if they're a plus 2 ion, your body might take it and use it instead of calcium because it just sees a plus 2 ion. And you get cool little effects like this is a large portion of what your teeth are made of, your enamel, calcium chloride. Anybody know what the charge of calcium is there? From naming last year? Plus 2, yeah. These will be their normal ones. You can just read them off the periodic table. What's the charge on chlorine? Minus 1. What do you brush your teeth with? Toothbrush. Louder. Fluorine. Specifically the fluoride ion. And what happened is that we used to be hunter-gatherers. We didn't actually have a problem with tooth decay. When we were hunter-gatherers, we didn't eat a lot of like starchy carbs. We didn't eat bread. We ate vegetables that would actually grind against our teeth a little bit and keep them nice and clean. And some meat. I mean, you could get cavities, but it wasn't as big a deal. And then we invented agriculture and farming and bread. And then all the carbohydrates and sugar started collecting in our teeth, and we would get cavities all the time. My parents, so like ZZ olden times, remember that a common wedding gift would be, this is before fluoride toothpaste, you would give them a gift of a dentist appointment. So you would pay to have all of their teeth extracted.
Extracted.
Yeah, like pulled out.
Why?
Nope, pulled out entirely, and then you get false sets. Because knowing that your teeth are going to fall out eventually anyway, you might as well do it now, get it over with, and get a nice set of falsies. People did that. So it's like pre-work. Like the teeth are fine, but you don't want to deal with cavities for the rest of your life. So pull them all out. My parents never did that. They knew someone who was older than them. One of my uncles did. And then right after that, they invented fluoride toothpaste. And fluoride turned out to be wondrous for teeth because bacteria can attack that bond and they can rip it apart. Fluoride to your body looks a lot like chloride. And what your teeth will do is fluoride is actually a little bit more reactive because it's higher up the periodic table. It's a little smaller, and it will get in there, and it will take CaCl2 plus that fluoride, and you get CaF2 plus Cl minus. That has a much stronger bond. Bacteria find it really tough to break that down. It takes a lot longer to form a cavity. And if you brush every day and keep fluoride over it, you don't get cavities nearly as often. And hence, now with agriculture, they discovered it because they went around the world and said, how can we fight tooth decay? And they noticed there were a certain number of indigenous people that just never got it. And then they were like, they found in some cases, it's their diet. And in other cases, it wasn't their diet because they had switched to colonist food and they still didn't get tooth decay. It turns out the springs were just a natural source of fluoride, so they were getting fluoridated water. When it first came out, you actually didn't have it in toothpaste. You take it in water and swish it around your mouth. One of my uncles, when he was a kid, his mom did that, and she read the labels wrong. He got it about 10 times too concentrated, put it in, turned all his teeth completely brown. He had way too much. Now, if you do that too much, it can get so hard it's brittle, and all your teeth break off. He got it right on the edge. They're so hard, he has never had to worry about cavities in his entire life. They are brown, but they don't seem to ever break. He got it right on that line. So he considers himself lucky. It is weird when he smiles, but he seems to think it's funny. So I guess that worked out. Yeah, what a guy. Now, a lot of this, we're going to use the valence electrons when we're talking about ionic structure and covalent structure. And it's a lot easier to do with Lewis dot diagrams. So now I have to teach you about Lewis dot diagrams, and there's a lot of boring rules for it. And I give you the rules because I'm going to do them, and I am giving you the most complicated way that will teach you right into university, chemistry 11, chemistry 12, it'll always work. There's a second way that is easier, but doesn't always give you the right answer. Commonly also taught, I will show it to you, and you're allowed to use it. It's not bad, but it doesn't need all the rules either. There's a couple of things we need to know. What we just learned is the octet rule. Everything wants about 8 electrons. The exception is hydrogen. And we don't put helium down because it already has 2, so we don't care about it. Just so you know, there's about 1,000 exceptions to the octet rule. It only really applies to the first 20 elements, and after that, weird things happen. But it kind of works a lot, so we're going to do that. But first, I have to teach you how to count valence electrons off your periodic table. So you get out your periodic table.
Which one?
Maybe the blank one. I think that would be more useful. Not the colorful one, because that'll just make it confusing. I'm going to teach you how to count. And I know how to count it, and I'm like, no, you don't. You don't know how to count. Now, first, how many valence electrons, based on what we just did, does lithium have? 1. How many does boron have? 3. And you should be able to go boom. One of the ways you can go boom, you don't even have to look at your table. Remember how it goes 2, 8, 8? And I remember that's reflected in the structure. So to get quickly the number of valence electrons, when I say boron, I highlighted things. I'm just going 1, 2, 3. It's 3. How many valence electrons does phosphorus have? 1, 2, 3, 4, 5. Right? You just count along, and you don't even have to do the whole structure. You can just count it, because the whole structure for phosphorus is 2, 8, 5. So if I was to ask you very quickly, Cheng Chao, how many valence electrons does carbon have?
4.
Excellent. How many valence electrons does aluminum have?
3.
Excellent. Oh, now it's dinging. Guy, how many valence electrons does fluorine have?
8.
Count again.
What?
7.
7. Excellent. How many valence electrons, Alexander, does chlorine have?
7.
7. Excellent. Now the piece de resistance, Natsuho, how many valence electrons does bromine have? What? For bromine. Element number 35.
Oh, yeah.
Just so you know, it's not a fair question. Because he's going to count, and he's going to give me the wrong number.
Is it 17?
No. Yes? You had your hand up. Were you going to say 17? Oh, okay. What were you going to say? Pardon? What? No? Any volunteers? Yes?
Is it -1?
Oh, no, number of valence electrons on the charge. Yes?
Oh.
7. The answer is 7. No. Trick question. Remember how I said it's actually way back when I said the electron structure is actually not 2, 8, 8, but 2, 8, 18, but this one gets filled up and then it disappears? because this one belongs to a previous level and then it disappears, once it's full, if I asked you how many scandium had, it has 3. But once it's full, it disappears. So you go 1, 2, skip a few, 3, 4, 5, 6, 7. You literally don't count the middle block. Because once these are full, they actually move electronically and mysteriously via quantum in the background somewhere else in a lower energy level. So if I say, as for fluorine, 7 valence electrons, 7 valence electrons, 7 valence electrons. How many valence electrons does iodine have? 7. And that now makes a lot of sense. These all have very similar properties. So those really do go. However, in here, we can't do that. So like scandium does have 3. But gallium also has 3. And their properties can be similar. Yes? Yeah.
Then where would like the other numbers be?
Scandium has 3 because it has 2 in what's called the S subshell and 1 in the D subshell, which if I go to, where's my screen? Here, and I can't rotate it. Oh well. It can, notice it says +3, it can lose all of those 3. But what it doesn't show you, and some of these have duplicates, scandium can be +1. And what it'll do is just get rid of this irritating one and be like that. And that is also stable for reasons that we'll do next year in quantum. And now please put everything away, put all your stuff except for your pencil and eraser, and you may use your own data booklet. Your data booklet, not your notes. So keep out your data booklet. I am first going to give out your answer sheet and just give you a couple of explanations, and then I will give out your test.
Wait, did you give us our data booklet?
I didn't take your data booklet. It looks like that, or it has a picture of a blue guy on it.
Oh, I think
This is your data booklet.
Oh.
So put away your notes, keep out your data booklet, put everything else off your desk, and spread out. Use the desk behind you. There's 2 spots where you can spread out on each desk behind you. Those can be crowded, and then you can also move around a little. So it'll be helpful if like you went one of theirs, one of theirs, and if you went to one of those or those. And then you guys are going to have to separate more. No. In fact, I encourage you to write in pencil. 2, 3. Because that way you can erase and then change your answer. You can write in pen and I'll still be able to mark the multiple choice. Like if the scanning function will still work. But then if you make a mistake and you want to change your answer, it'll be really hard. 1, 2, 3, 4. Can you pass this behind you? I can't quite reach. Okay. Just a couple things on the sheet in front of you. You don't have a data booklet?
No,
Do
he
you
didn't
not
get the
have?
sheet.
Oh, right.
Yeah. I need to test. I don't.
Do you have the answer sheet?
What?
You didn't get one of these? There you go. Does everybody have one of these? Everybody has a data booklet? Everybody has their binders off their desk and away. Binders off the desk. Binders, like no books. Everything away except what you need to write the quiz. I keep saying test, I mean quiz. You guys have to separate a little bit more. Like literally move your desk. Maybe if you moved up or something. You can move up. Not you. There. 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 Excellent. Okay. You guys are going to have to separate a little bit. You could really separate and then you could go backwards. And then it's fine. We are B block. B. B is in bat or balderdash. Okay, on this sheet, yes, your first and last name, please. Give it a quiz name that makes sense to you. Quiz. Bohr model and definitions or something. Put down your block, URB block. You can leave your student ID blank. Do not write anything there. You can leave the version number blank, even though your quiz has a version number. Just leave it blank. There's something you have to set up first. And not everybody, it turns out, knows how to fill in one of these, it turns out. So, just in case, I just wanted to go over, if you were filling this in, and you think C is correct, don't do this. Oops. Can't read that. Don't do this. Can't read that. Please fill it in. You don't have to spend hours making it dark, just fill it in. It can be in any type of pencil or pen. I prefer pen, so if you make a mistake, you can erase it. Later on, you will be able to see a copy of it, so you can see if the machine read it incorrectly. Any questions about that? Okay, when I give you your quiz, you're going to have 2 leftover questions on this sheet. There's only 8 multiple choice. Please leave them blank. I do use them for something. There are 2 long answers or short answers on the quiz itself. Just write directly on the quiz for that section. And when we begin, as soon as you get your quiz. The quiz is now being handed out. You can no longer talk. Gentlemen, no talking while quiz is coming out.
Can we start?
You can write right on the quiz. You can write all over it. Given that, do you not have to? Is there anyone who's missing either an answer sheet or a quiz? Given that we are before lunch, as soon as you're done, you may go for early lunch.
Can we edit this thing?
Hmm?
Can we edit this?
Right on it.